I'm Cathal Summers.
And I'm Deirdre and Cathal.
Your Teagasc Sustainability Advisors. And you're welcome to the Teagasc Environment Edge podcast number 40, bringing you the latest information, science and opinion to improve farm sustainability.
With ever-increasing pressure on dairy farmers to meet the challenges of sustainability and with greenhouse gas emissions currently to the fore, what work is being carried out to support dairy production systems?
Lorraine Balaine, Teagasc postdoctoral researcher working on a European project called MilKey, joins us to discuss just that. Lorraine, I suppose you're working on a really interesting project. Can you tell me a little bit about MilKey and what's it all about?
We try to assess the economic, environmental and social sustainability of European specialized dairy farms. So we mostly conduct a case study analysis with farms from different countries like Ireland, France, Germany, Poland, Greece. And we try to identify win-win practices for sustainable and GHG optimized dairy production systems. So it's a quite ambitious project, and as part of that, we've conducted a multi-criteria sustainability assessment and estimated also GHG emissions on these case study farms.
You're mainly looking then at it's sustainability as a whole, or are you focused mainly on greenhouse gases?
A bit of both. So the idea is to identify GHG optimization strategies that will not negatively affect other sustainability aspects. So in order to do that, we sort of look at different indicators of sustainability, but there is a large focus on GHG emissions.
So there's an interview process with the farmers, is there, to try and select them for the project?
Yes, so the idea basically was that each project partner had to select farms that would be representative of the national production systems, and then in that, visit the farms and collect information from an environmental, economic, and social perspective to then populate sustainability indicators that we'd selected previously with an expert group. It was actually a quite long interview with farmers. So I collected that data in Ireland on 3 different farms, and the interview lasted about 3 hours. So this is the amount of time you need to collect just the environmental data, actually, because the economic data was already collected by other people in Teagasc. So it gives you an idea of the amount of work, of the time needed from farmers in order to collect information necessary to do these type of assessments.
You have a number of farms in Europe and you have 3 in Ireland, and you needn't name the farmers now, but what parts of Ireland are they in?
I'm in Galway, a farm in Laois, and one in Cork.
Oh, nice mix. So you have a mixture of soil types, and are they all, they're all dairy producers. I suppose, tell me this, how did the farmers take to you calling up to the farm to interview them about this kind of thing? Did they find it positive, or were they a little bit worried about it first? Or
because we were looking at case studies and the participation was voluntarily, they could say no if they weren't interested in participating in the project. So when I recruited them, I actually spoke to them on the phone and presented the project and the ambition that we had. So I was received very well then when I visited the farms, because they already knew what the work was about.
I know you were up at Johnson Castle at the Open Day there a week or 2 ago. What's your general perception of farmers in Ireland, their understanding of the crisis ahead and greenhouse gas emissions?
Generally speaking, I think that nobody denies that we are facing climate change. Now, how the reduction efforts needs to be distributed across individuals and industries and sectors is kind of, there's mixed opinions there. But generally speaking, I find farmers to be interested, to some extent, or trying to understand better what the situation is or what is expected from them. So there's also some level of, I wouldn't say sadness, but it is also hard to see for farmers to see the amount of things that we expect from them. We expect them to produce food. Now we expect them to reduce emissions. We expect them to do this. And I think there's not a lot of industries out there where the expectations from the general public are that high, and that can make farmers feel, a little bit isolated.
Lorraine, why are you estimating the GHG emissions on these farms?
So I suppose, we have international, European and national commitments to reduce GHG emissions. So this is, now the Irish government actually has put this into law that we need to reduce emissions. And why has the government done that? Well, I suppose there is kind of an element of the right thing to do because we are in the middle of a climate crisis and we're trying to not hit the wall and act now. So I suppose the targets, the sectorial targets that have been detailed in 2022 now recently by the government to reduce emissions for the different sectors of the economy, we have one for agriculture that's 25%. These are based on the national inventory figures. So, we use aggregate figures of fertilizer sales or total animal populations to estimate that. And these are aggregate figures for the whole agricultural sector. But then the trends that you observe in these figures, obviously they depend on the individual behaviors that happen on farms. Okay, so all the farms are, all these GHG that are generated on all specific farms, they're all aggregated, and that gives you the overall figure. So in order to decrease the overall figure, you need to observe decreases at the farm level for all these individual farms. So obviously you cannot change what you don't measure. So we do these GHG estimations at the farm level in order to identify areas of improvements for different farms. So that would be kind of the advisory aspect of it, so help farmers in the transition. And then there is also obviously a monitoring aspect. So we are trying to demonstrate as well that there are reduction of efforts being undertaken on these farms. And we are trying to assign a figure to that reduction when farmers use new technologies that will lead to lower emissions and stuff like that. So there's also a bit of a monitoring aspect, I suppose, to it.
So how are the emissions actually estimated on the farm? How do you go about doing your job?
So this obviously, you probably all have heard of different methods like the IPCC method or the LCA method, but the idea behind all these methods is the same. So you basically have two components that come into play when you do these estimations, and that's the activity data and the emission factors. So the activity data, that's specific farm information that will vary across farms depending on the characteristics of the farm. So that can be, animal numbers by category of animal or age. That can be the total amount of fertilizer used. That can be days at grass versus day housed by animal type, stuff like that. And then on the other side, you have these emission factors. So those are basically the way to think about it is it gives you an average amount of GHG emitted by item that generates emissions on the farm. So say, for instance, different animals, they emit, so say dairy cows, for instance, during enteric fermentation, they emit X amount of methane. And so science develops emission factors that will give you an average value for the amount of methane being emitted. And when we do the estimations at the farm level, we use those coefficients, those sort of average coefficients, and we multiply them by the amount of dairy cows that will be on the farms that is currently under study, right? So you've got those two different components. And I suppose for the emission factors, as I mentioned, it's science that develops them. So when you're talking about, say, for instance, estimating the emissions from excretion at pasture from different animals, well, you've got people in Teagasc that go out to fields and do field measurements of the amount of gases that are being emitted when the cow deposits excreta on the field or urine or stuff like that. So there's a lot of work that goes behind these assessments from basically science to develop these coefficients.
So would housing design and, diet or stressors have an effect then on the amount of emissions that an animal will produce? And is that comparable within those three farms that you've selected?
These things do matter for the amount of emissions, and then whether or not we are able to show these differences across farms kind of depends on the method that you use, and it also depends on the advancements of science for that specific aspect. So I suppose an example would be, for instance, dairy cows don't emit the same amount as young cattle, right? And we have emission factors that take that into account. So we have specific emission factors for dairy cows, specific emission factors for cows under one, then for yearlings, for in-calf heifers, all of that. And this is currently taken into account in Ireland. Now, you can also have breed variation, right? So a Jersey cross or a purebred Jersey or a Holstein Friesian will not emit the same amount. And that is not currently taken into account so well because we use average values for dairy cows. So this is kind of a simple example, but if you talk about diets and stuff like that, it's kind of a similar principle. If you want to take into account differences in diets, then you need to develop emission factors for that specific cow eating that specific diet.
So yeah, it gets very complicated.
It gets
yeah.
And not only that, it gets complicated to develop the emission factors, but it also gets complicated to access the detailed information from farmers in order to multiply these emission factors by the farm-specific data. So if you want to see that in the assessment, then you have to ask the farmer, what breeds do you have? How many animals are this breed versus that breed? What do you feed to this specific cow versus, that one, or stuff like that? So it gets fairly complicated.
Isn't it all very confusing? If you think about, you see 25% reduction in emissions, and then we hear, if you're a farmer sitting at home and you hear about the IPCC method and the LCA approach, and we've all these different emissions. You just mentioned all the variables that have to be built in to measure our GHG emissions. Do we need all these approaches, the IPCC and the LCA, or why do we use two different ones? Is there no one size fits all, or is it too complicated to do that?
Good question. And I think that because of these different methods, there is a lot of confusion out there in terms of what they can do and why we use them. So I suppose if we talk about the IPCC method first, what the IPCC method does is it only estimates on-farm emissions, right? And it also doesn't take into account the level of output from the farm. So, and that kind of stands in contrast with LCA method. And I suppose IPCC originally, the IPCC developed that method not to do farm level assessments. They developed that method to establish a national inventory of GHG emissions. And that explains why things are the way they are. Is like, because we needed to do a national inventory, we needed hard boundaries between sectors and hard boundaries between countries. And what I mean, and the reason for that is to avoid double counting, right? So if you take an Irish farm and that farm feeds concentrate, and one of the components of that concentrate comes from Brazil, right? This component is being produced in Brazil, and thus the GHG emissions that are associated with the production of that component will be taken into account in the Brazilian national inventory following the IPCC method, and not in the Irish inventory. And we don't take it into account in the Irish inventory because that would be double counting, because we're trying to do an inventory of all GHGs that are being emitted on the planet, basically. So now, because the IPCC is practical, we are using it to do farm level assessments, and it does give an idea of what is happening on the farm. And what I mean by practical is that it doesn't require as much data as an LCA model. Now, moving to the LCA model, the LCA actually estimates on and off farm emissions associated with farm production. So, for instance, a farm that feeds a lot of concentrate, that stuff in the IPCC would not be taken into account because it's not produced on the farm. But in the LCA, it will be taken into account and as off-farm emission, right? So the LCA also can be basically as detailed as you want. So it can take into account the levels of output from the farm. So if you push concentrate use, you may push output as well. And in the LCA, you sort of take that into account. So obviously, it's more precise than the IPCC, but because it's more precise, it requires a lot more data, and it's a lot harder to do those estimations because you need more emission factors. So it kind of explains why sometimes we turn to the IPCC to have kind of a general idea of what the emissions are on these farms. So
if you wanted farmers to work with you as well, with it being such a cumbersome model,
mm-hmm.
The PCC one would work better.
You made an interesting point there as well. You spoke of, say, the Brazilian beef or Argentinian beef coming over here, and that's one thing we focus on a lot here, isn't it? We're really carbon efficient when it comes to dairy production and also beef across Europe. So when we export our products, we want to get that credit for that.
Because the idea behind these efficiency measures, like emission efficiency, it's all usually based on LCAs. So in that case, you also take into account the off-farm emissions, and that gives you, this is what you call the carbon footprint. And I think what is a little bit hard with these efficiency measures, the first thing is it's not that easy to compare the emission efficiency between different production systems in different countries, because the modeling approach might be slightly different. So generally speaking, I would be quite careful to compare, the carbon footprint that comes from different models, different research institutes, because, unless you put your nose in the actual model, you might be comparing carrots and apples,
You have different variables, yeah.
Yeah.
So how are the GHG emissions reported at farm level?
So yeah, this follows up actually from the efficiency talk there. We have multiple types of measures, and they tell different stories. So we have this efficiency measure that looks at GHG emitted per kilograms of output. So for instance, for a dairy farm, that'll be kilograms of milk. And we then have also measures that look at GHG emitted per hectare. So that's more of a GHG emission pressure measure. And they tell different stories because depending on the profile of the farm, you may observe high efficiency, but also high pressure, or you may observe low efficiency and low pressure. And what is right and what is wrong is, up for debate, I suppose. But so say, for instance, a very intensive farm that uses quite a lot of input, has high stocking rates and relatively high output. So, within the Irish agricultural sector, that could be a dairy farm. They would generally have quite good emission efficiency or emission intensity, but they also have much higher emissions per hectare. If you take the case of a farm that is more extensive by nature, so lower amount of inputs, lower stocking rates, but also lower amount of products being produced, they would have low emission intensity, but they also have low pressure. And so you do have this this relationship, this trade-off between efficiency and pressure to some extent. And by nature, because this relates to the actual characteristics of the farm, it is quite hard to find a farm that has both high efficiency and low pressure, which is what you would want really. But it's not that easy because there is a trade-off there.
Just to finish off, I suppose as well, Lorraine, what does that GHG emission, you mentioned a profile on a dairy farm, what does it look like, and can we use it in some way to learn from it or do something with it?
GHG profile it's basically gives you a breakdown of where the GHG emissions come from on the farm. So say, for instance, how many, what is the share of emissions that come from, say, enteric fermentation versus mineral fertilization versus energy consumption. And I think that sometimes farmers think that energy consumption represents a large amount of emission on the farm, but it's only about 4%. So by energy, I mean electricity and I mean fuel consumption. On dairy farms specifically, the largest contributor to GHG emissions is enteric fermentation. In 2020, based on the Teagasc LCA model, it was about 47%. And then, say for instance, fertilization, they only represented, sorry, I have those figures somewhere actually. They represented much smaller amounts. So say, for instance, mineral fertilization, that'll be about 12%. Organic fertilization and excretion at pasture, that'll be about 9% of the emissions. So if we manage to reduce the emissions in one of these categories, and we don't tackle another one, obviously it puts more pressure on the other one. So say, for instance, enteric fermentation representing such a large share of emissions, if we don't tackle emissions at all from enteric fermentation, it puts more pressure on other parts of the farm. So say, for instance, fertilization, to do a lot of effort to reduce the emissions so that we actually meet those targets. And so at the minute, if you look at the recommendations that we do to farmers with the MAC curves and all of that, a lot of it comes down to emissions from soils, so fertilization, soil fertility, all this sort of stuff. And then we also tackle enteric fermentation to some extent with efficiency measures. So we try to improve basically animal performance, avoid wastage. So what's the idea there? The idea is, to reduce age at first calving, cull cows that are not being productive anymore. And we do that so that we dilute the fixed environmental costs that are associated with animal growth and maintenance. And you do that to reduce basically the amount of GHGs that are emitted over the lifespan of the animal. And those efficiency measures, they work only if farms don't increase in size or don't start basically using a lot of additional inputs, if that makes sense. Like efficiency works only if you don't increase the scale of production. And I suppose in the last 5 to 10 years, what's happened in the dairy sector is that farms have actually increased production scale quite a lot. So they've improved emission efficiency, but the direction of travel in terms of absolute emission has not been satisfactory. It's been actually quite negative, and this is because of this difference between efficiency and pressure. That kind of, I suppose, the main message when you look at the GHG profile is that without looking at enteric fermentation a bit more, it'll be difficult to meet those targets because it has such a large it's such a large contributor to GHG emissions. And that's why you have a lot of research that's being done on feed additives and stuff like that to try to reduce emissions that come from enteric fermentation at the minute.
Lorraine, farmers are really interested in trying to update themselves and educate themselves on exactly what you're talking about. It's a very complex area, and I'm sure they'll appreciate that there's projects out there working hard at a farm level that can actually support them in trying to achieve our targets and our goals. So really enjoyed the chat today, and thanks a million. Keep up the good work.
Thank you very much.
That's it for this episode of the Teagasc Environment Edge podcast. Thanks to Lorraine Balaine, postdoctoral researcher working on the MilKey project, for joining us on the show.
Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to Teagasc website at teagasc.ie. I'm Cathal Summers.
And I'm Deirdre and Cathal.
Join us next time for the Teagasc Environment Edge podcast, signpost to farm sustainability.